Now, for the first time, we're going to filter blood. So the spleen has two functions. You can see, well, the next image, or they're over here, you can see better. There is red pulp, and the dark purple here is actually white pulp. So if you look at a raw cut spleen, it looks more white. It has white blood cells in it. So the red pulp has red blood cells, and the white pulp has, big surprise, white blood cells. So the white pulp functions as the side of the lymphatic function for the spleen, similar to what we've been doing in the lymph nodes. All right, passing the fluid, which is blood this time, through a series of lymphocytes and macrophages, in case there happen to be any pathogens in the blood. And so, much more important than in the lymph node are the blood vessels that come into the spleen, which we're already familiar with. All right, is a branch of the celiac trunk. We have the splenic artery, and then leaving we have the splenic vein, which forms the hepatic portal. So we also have a capsule with the spleen. And the unique aspect of this capsule is the presence of smooth muscle. All right, none of the other capsules have a smooth muscle. And we have some segmentation, but we don't separate the spleen into cortex and medulla, even though there are septi, segments formed by connective tissue. We don't have a separate set of cortex and medulla regions. So we're going to add smooth muscle to the capsule and to the trabeculae. So that is unique to the spleen. Anybody think of a reason for the presence of this smooth muscle? I'll give you a hint. It has nothing to do with the white pulp. It has to do with the red pulp. And what does muscle do? Unique to any other type of tissue. It contracts. All right. So if the smooth muscle in the capsule contracts and it squeezes the spleen, what might happen to the red pulp? Blood. So the spleen functions as a storage site for red blood cells. That's what the red pulp is. There are unique vessels at the terminal ends of arteries coming in. And red blood cells, erythrocytes, which are by far the highest concentration, allows the red blood cells to leave those vessels, and it stores them. Now, as I told last night's class, there hasn't been any experimental proof in humans that this happens, but when they put dogs on treadmills and they had oxygen deficit, the smooth muscle in the spleen would contract. That increases pressure, and that would push red blood cells back into the circulatory system for the dog's cardiovascular system. And as we learned with the red blood cells, their function is oxygen transport. So this would be a natural blood doping, not even having to take your blood out and store it in a refrigerator somewhere. Adding additional red blood cells to the circulatory system from the spleen would increase the amount of oxygen transport. But as we know, it would also increase viscosity, right? Which could affect blood pressure. All right, so that's the purpose of the red pulp. So if someone had to have their spleen removed, it's very what we call friable. It's basically a bag of cells, the white blood cells and the red blood cells. And if that bag gets torn, then it's very difficult to put it back together again. Okay, so it's not unusual to just go ahead and remove the spleen. It's tucked up under the rib cage in the abdominal cavity, but under the rib cage where that dome-like arrangement of the rib cage is formed. And so car accidents, bicycle accidents, anything that breaks the ribs can cause laceration of the spleen. And if it's multiple lacerations, then more likely the spleen will be removed. And they lose this ability, the person would lose the ability to store their red blood cells. So they're more likely to get fatigued without that second wind type of component. All right, so we have the white pulp, which is the white blood cells. but it's arranged slightly differently than we see with the lymph nodes. Remember, this is arterial filtration, and so the splenic artery coming in sends multiple branches, much smaller than I'm taking the time to draw out. These branches are known as central arteries, when in fact they're actually arterioles. And I'll work with this one up here. But they are leaky enough that pathogens and blood content can leave the blood vessel, all right? So we'll name this as a central artery, okay? However, in the name of the white matter, it's considered to be an arteriole. So if you look at up here, the lymphocytes, instead of forming a sphere, form a cylinder along the length of the central artery. However, when we cut it in cross section, it's going to look like a circle. Okay, so it looks very much like a follicle when we look at it in the histology. So here's our central artery, and it tends to not be in the very center of the cross section, usually because the germinal center has formed. And that's what it looks like in a cross section of the central artery. So just from that, you can tell it's not a lymph node because we don't have those blood vessels in the middle of our follicles. All right? So instead of a follicle, what this is identified as is a periarteriolar. There's where the word arteriole comes from. Periarteriolar lymphatic sheath that forms a sleeve around the blood vessel. And the acronym for that is PALS. Okay. So the white, okay. So running along that vessel. So periarteriolar lymphatic sheath is the same as our white pulp. It makes up the white pulp. So in this image, there would be the periarteriolar lymphatic sheath. Here would be a blood vessel. Okay, that would be a central artery. Here's a couple. Here's a central artery. All of these little white circles would be the central artery surrounded by the white blood cells. But because they're basically cut in transverse cross section, we don't see the elongated view except maybe in the upper right there. So that would be the pulp, the white pulp, and this would be the red pulp, where the red blood cells are being stored. Okay. Now, you don't have to learn the names of these vessels, but notice the simple squamous epithelia of these blood vessels are formed like the staves of a wine barrel. Instead of being in a circular fashion, they're lengthwise, and that creates narrow sites where the red blood cells leak out. And they still have to slow down to do so, and if they're older, remember we said red blood cells have a lifespan of about 4 months, 120 days. And if they're close to the end of that, their membranes become much more fragile, and they may break or rupture as they move through those spaces. And so the spleen, like the liver, is a region where red blood cells can be broken down and recycled. And it's kind of, if they can't make it through that, they need to be recycled. All right, so back to that scenario where the spleen is removed. So we lose the red blood cell storage for additional red blood cells to be added if we need additional oxygen. And now we've lost the white pulp, which is our only site for filtering the blood, in case there happens to be some type of a blood infection. So it's pretty standard practice if someone does not have a spleen, that they take a preventative prophylactic antibiotic prior to any dental hygiene or any dental work, just in case that introduces, because a lot of people's gums can bleed during that process, and there can be some introduction of bacteria from their mouth. And so because it don't have the spleen to clean out their blood. If that's not done, they can get sepsis or endocarditis or bacteria settle on the valves in their heart. Okay. So characteristics of the spleen: has a complete capsule similar to the lymph node, only this time it has smooth muscle in that capsule. No afferent lymphatics, but there are efferent lymphatics coming out of the hilus. Obviously, the presence of the red pulp and the white pulp. And the filtration of blood instead of the filtration of tissue fluid. Okay, that's the last of our lymphatic organs that actually function in a direct defensive activity of the body, where we are using macrophages and B lymphocytes to phagocytose antigens and present them to the B cells and T cells and develop an immune response. And that process we'll look at on Thursday. The last organ we're going to talk about is the thymus, which we looked at for our endocrine system. And the thymus is an immune organ, but it's not involved in directly protecting the body. It's a nursery. It's where the T lymphocytes develop. So this occurs up until about 2 or 3 years of life. So in the microscope slides I have over here, to look at the thymus, it's identified as a fetal thymus. Okay. Make sure it's darkly stained so you can see the components more easily. There's a pink one over here, but I would look at the purple one. And it's often half or larger the size of the heart, and usually above the heart as well, not just the great blood vessels. And then as a child gets older than 2, the epithelial cells, the thymus is an epithelial tissue organ, an endocrine organ. The hormone it makes is called thymosin, and that really just keeps the epithelial cells functioning, and they don't work the hormone doesn't work on other sites predominantly. And so as the individual gets older, the thymus epithelial cells die and are replaced by adipocytes. So they don't change to fat cells, they just are replaced by fat cells. So the purpose of may I erase the board? The purpose of the thymus is as a nursery, if you will, a protective growth site for T lymphocytes. Hence the name T lymphocytes from thymus. Okay, the B lymphocytes mature in the bone marrow. However, the letter B comes from a bird organ, the bursa of Fabricius, rather than bone marrow, but it still works since bone marrow starts with the letter B. So, let's look at histology first, and then we'll talk briefly about the function, although we'll look at it more on Thursday when we talk about T cells. This is from a preserved cat. So this is the heart with adipose tissue over it, and this is the size of the thymus. All right, so this is not a fetal cat, it's mature adult cat, so I'm surprised that you would found one there. More than just adipose tissue. Lung, the darker red-brown material on either side is lung. So I'm going to move through these slides. Here's a low-power view. This is what you would see probably on that dark bluish-purple slide. The thymus has a cortex and a medulla, but each of these structures are known as lobules. All right. So there is the dark area would be the cortex, and the light area would be the medulla. No follicles. The thymus does not have follicles. It's not functioning as a filtration system. It's functioning as a site to ensure that the T lymphocytes have 2 characteristics in their ability to detect foreign antigens and yet not break down, not attack the self organs of the body. So as I indicated, cortex medulla for each of these lobules, rather than just one cortex around the outside of the organ and the medulla in the center like we saw for the lymph nodes. The Hassel's corpuscles are just a unique arrangement of thymic epithelial cells that help you identify the thymus if you happen to see them up close. And so what happens is T cells that have been made in the bone marrow, so that's their origin, is still the bone marrow, will migrate out of the bone marrow into the outer edges here of the lobules, into the cortex, and then gradually move towards the center, towards the medulla, and then finally leave via efferent lymphatics. So again, the thymus does not have, it has a capsule, but it doesn't have afferent lymphatics. It doesn't have follicles, but it does have the efferent lymphatics. And so as it moves through, here's a closer view of the cortex and medulla for each lobule. We'll come back to this question. So as it moves through, the purpose is to provide an opportunity to test these maturing lymphocytes. And I don't know how many of you have had micro, but the antigens are presented to macrophages or to T cells via what are called major histocompatibility complexes. We'll talk about those on Thursday, okay? Type 1 and type 2. So a lymphocyte, especially our T helper cells, which activate both B cells and T cells, have to be able to recognize that complex, to interact with it. If they don't, then they're no good to the body, all right? So they have to be able to recognize that. If they don't, they are triggered to commit cell suicide, which is spelled like this. The second P is silent, so apoptosis, okay, or apoptosis. That's cell suicide. So if they cannot recognize the MHC complex, they're triggered to kill themselves because they're of no use to the body. Then they are exposed to self-antigens. So various cells throughout the body will move through the thymus, and we have those self-antigens held by our MHC complexes on our body. And we don't want, while we want the T lymphocytes to recognize the MHC complexes, we don't want them to react to self-antigens. That's where autoimmune diseases start. That's how we make antibodies against acetylcholine receptors if you have myasthenia gravis. That's thought to be a component of lupus, well known to be a component of lupus, and how diabetes type 1 can occur. So they have to recognize but not have a strong response to the self-antigens. So if they do have a strong response, then that's another trigger for them to commit suicide. So that's the purpose of the thymus, is to be a center for the maturation and selection of competent T cells. And that's done by the time you're 2 or 3 years old. Okay? For a long time it was thought that once you were an adult, there was no capability of making any more T cells. And with the study of HIV virus and AIDS, which destroys the T helper cells, came an interest in, can we get more? And so I'm not sure where it is with humans, but they have found a few isolated T cells in adult thymuses of mice, which we know of just like humans. And so that was their thymus made, but the mice don't. And so now that's kind of driving research to see if T cells can be developed in adult humans. But I think the medical treatment for AIDS is much more advanced in trying to find replacements for T cells. Alrighty, so while it's a lymphatic organ, it's not involved in any filtration and any removal of pathogens. It's a site for T cell development. Alright, we're done. I think we finished 2 minutes earlier than last night. We will have the lab